This page of problems comes from old exams. It addresses the issue of the method of sections. If you cut a truss and end up cutting more than 3 unknowns. In the previous examples we worked, we cut a truss, for example, we cut a truss like right here. And if you cut 3 unknowns and draw a free body diagram of that guy, we can write 3 equations to get the 3 unknowns. 2 moment equations and 1 force summation, maybe 2 force summations and 1 moment equation, but you can solve for all 3 unknowns. But some trusses have more members in them. And if you cut them, you end up cutting 4 members. And so the question is, can you solve for all 4 of those members? Or can you solve for 1? Or can you solve for 2? And that's what all of these questions address, that issue. Here's a good example down here. This problem basically says you've passed this section right through here. Looks just like that. And you've cut 1, 2, 3, 4 different members. And if we took basically this piece of the truss right here and solve for him, again, there's 1, 2, 3, 4 unknowns. And the question is, and I can't solve for all 4 because I only have 3 independent equilibrium equations I can write on a sections problem. But the question is, can I solve for 1? Can I solve for 2? And if you look at this guy right here, there's 3 unknowns, this one, and this one, that all intersect at point Q. And then you've got this guy out here, which is like FCK right here, that doesn't intersect Q. And so the question here is there one equation that you can write to get the force in this member? And again, you've cut 4 unknowns, but you can sum a moment about Q, which eliminates these 3 unknowns to get FCK. And so that's how you would answer that question. This question here basically says, okay, what if you pass a section through here, which is legal, you can do that. The question is, can you find a force in AD, which is this guy right here? Can you find him? Remember, we've actually cut through 4 members. 1, 2, 3, 4. And again, I can't write 4 independent equilibrium equations. But that's not what the question's asking. The question asks is, can you find AD? Can you find AD? Well, if you sum moments about C, this unknown passes through C, this unknown passes through C, and the line of action of AB passes through C. And so if you sum a moment equation about C, we can get AD, this guy here. You could sum a moment equation about A and get CE. But you can't find these 2 guys, AB and BC, you can't find those 2. So you can get, so of these 4, you can get 2 of the 4. Some moments about A to get CD, CE, some moments about C and get AD. So back to our method of sections. Again, we only have 3 equilibrium equations. Once we cut a truss, we can solve for, at most, 3 unknowns. Here's another example here. So it's a challenging truss. I mean, none of these members are parallel. That's parallel to that parallel, but they're at odd angles. So we pass a section through here. We've cut 1, 2, 3, 4 members. And the problem says, what equation of equilibrium can I write to get the force in member FH up here? And it looks like they took the left-hand member because these are, the correct answer is something about G. But if you look at these two free bodies, there's not much hope using the right-hand free body. Well, no, that's true. Yeah, you can. So either whether you use the left-hand free body or the right-hand free body, this unknown, this unknown, this unknown, all pass through G. This unknown does not. And so if you're on the left-hand free body, you can sum moments by G to get this guy. Or if you're the right-hand free body, you can sum moments by G, which is not on the free body, but it's still, you can still project these three unknowns to that point, and you can still sum moments about that point as. So again, I can't get all four, but I can at least get one if I sum moments about these unknowns. Finally, this is a similar problem. This is called a K-Truss, because all of these members are like repeating Ks. And something you're noticing here, we haven't talked about in our truss analysis, is there's some trusses that have too many members to analyze. And we just simply run out of equations that we can write. Most of the homework problems that you have, all of the problems I've worked so far, had just the right amount of members that it's pretty easy to solve with our methods. In these double crossing methods here, a single diagonal would keep this rectangle in equilibrium. The double cross members is redundant. One of those is not needed for static equilibrium. So if you remove one of these, it becomes statically determinate. But coming back to this K-truss, the question is if we pass a section through here, we've crossed 1, 2, 3, 4 members. The question is, can we write one equation to get the force in member FG? So this is FG. Can we find this guy? And we basically did it on a previous problem. So you basically have an unknown here, you have an unknown here, you have an unknown here, and an unknown here. If we sum moments about this point right here, this unknown, and this unknown all pass through that point. So if you sum moments about, this is X, about X, then you can get FFG. And if you sum moments about G, then you can get FWX. So this is W and this is X, so you get this force. So we can get 2 out of these 4 with using 2 different moment equations, carefully chosen moment equations. We can't get these 2 unknowns here that are collinear with one another. Forces that are collinear with one another, we saw that back in 3D equilibrium, like with hinge type problems. And when you have 2 forces that are collinear with one another, they're redundant. And we don't have an equation to solve for them. So again, this example problem, we looked at several examples, real test type questions that show up on exams from time to time, where when you use the method of sections and you cut more than 3 members, the question is, even though I have 3 equations of equilibrium maximum, can I get something? I can't solve for all 4, but can I get something? And what we've seen in these examples is yes, by a carefully chosen moment equation, I can still get 1 or 2 answers out of the 4.